All right, we're going to go ahead and get started on homework number 10. And the name for this is solving systems. Now, we've been solving systems here for over a week, and we've been solving systems by graphing, but today there's two main ways we're going to talk about in order to solve systems, and that's by substitution and by elimination. And the first few problems deal with substitution, so I'm going to take them one at a time. Basically, there are multiple ways to get to an answer. The same way there's multiple ways to get to a destination. You know, if you put an address into your GPS, you could be taken one of several different ways. And maybe depending on traffic, you could alternate your route and move to another way of getting there. So in solving math problems, there's not always just one way of doing things. And sometimes there's not even necessarily a right way. There are ways that are maybe more efficient than others, or maybe some people just really like one method over another and just decide to do that. So when we solve these systems of equations or systems of inequalities, we're trying to find a solution. And I have it written in here. It says a solution of a system is a set of values for the variables that make all the equations true. Okay, so we're going to be solving systems. There's multiple ways of doing it. We did it last week by graphing. And this week we're going to talk about two other ways. We're going to talk about how to solve systems via substitution and also elimination. Now, this is nothing new. We've talked about this before in Algebra 1. It's actually from teaching Algebra 1 a few years ago. It was Chapter 6, and we dealt a couple days talking about how to graph and solve these systems, and we moved to substitution and elimination. This is more of just a refresher that as we move forward, it's important to know this stuff, especially, I'd say of the three, substitution, in my opinion, is the most important. So that's what we're going to start with today. So in the first problem, it says solve each system by substitution. And they've given me two different equations. Okay, so I have 3x plus 2y is equal to 68. And I also have that is not number 1. 3x plus 2y is equal to 2. And then y is equal to 4. I was looking at number 2 at the same time. All right, that's the right equation. Those are the two right equations. So remember, I said we're going to talk about how to solve via substitution. I definitely did not spell that right. Let's see, substitution. I don't know, maybe I did spell it right. It just looked weird. Just wrote it down, looked weird. So, solving via substitution. I'm going to write a few steps. The first step, in order to solve systems via substitution, the first step is to isolate one variable. Doesn't matter which variable it is, and I'll say doesn't matter which one. Okay, and in this case, we already have y isolated. And remember, when I mean isolated means it's all by itself, right? That's the definition of isolation, is by itself. So you want one variable by itself. And in this case, so isolate one variable, I'll say, of one equation. Okay, in this case, we have y equals 4 right there. Y is by itself. Perfect. We don't even need to do step 1. Most of these, we're going to have to do that. So that's an important step. The second thing I'm going to do is I'm going to take the variable of whatever I have. So y is equal to 4, right? And we also have a y, well, I guess I'll say this, right? if we have a y down here and a y up here, and we know that y is equal to 4, I can substitute this value into the y there, right? Because if we know y is equal to 4, I can substitute that value in, right? So I can say take value and substitute into the other equation. Okay, so in this case, we have a 4, so I'm going to go ahead and substitute that in. So the new equation, what I'm working on, will look like this. So we'll say 3x plus 2 times 4 equals 2. All right, now I'm going to go ahead and simplify. All right, I'll say 3x plus 2 times 4 is 8 is equal to 2. Okay, now I want to get x by itself. I eventually want to isolate x by itself. All right, so maybe I'll add this step in here. And then I'll say solve the equation. So I'll move through here. If I want to get x by itself, I need to subtract 8 from both sides. And I'll say 3x is equal to negative 6. Divide each side by 3. I'll say x is equal to negative 2. Okay. And I'm going to go ahead and circle that. But I'm not done. Okay? You're not done yet. Now that I have this, I'm going to go ahead and substitute this value back into one of the equations. It doesn't matter which one. In this case, I can only choose the first one because that's the only one with the x in it. Right? So now that I've solved the equation, I'll say take answer and substitute into one of the original equations to solve for the other variable. Okay, so in this case, I have x, and the next step is to find what y is. But check this out, I already have y is equal to 4 here, so I know y is eventually going to equal 4. Not all of them are like that, so I'm going to walk you through and show you this way, right? So you could say 3 times negative 2 plus 2y is equal to 2. 3 times negative 2 is negative 6, plus 2y is equal to 2. I'm going to add 6 on each side. Say 2y is equal to 8. Divide by 2, and I get y is equal to 4. And circle it. Okay. So now I went ahead and solved for x up here and for y down here. Now the last step is to check your work. And the way I can check it is this x equals negative 2 and y equals 4 should be a solution. So I'll say your answers should work in both equations. Now, in this case right here, remember how I said in the beginning, I said, oh, well, x is equal to 4 up here. I don't even need to do anything. Well, I showed you that because we're not always just going to have, like this was the easiest problem you're going to get, okay? And we already knew what y equals. But if we were to substitute that back in, x equals negative 2, 3 times negative 2 is negative 6, plus 2 times 4 is 8. Negative 6 plus 8 gives me a positive 2, okay? So I've done that. So I don't know if you want to write that down, take notes on it. This is going to be important. These steps, these 5 steps, are going to be important for the rest of this work. Okay, so for the next, I don't know, all the way through number 11, you're going to be through number 6. You're going to follow these steps. All right, so let's move to the next one. Okay, number 2. Number 2, I have x plus 12y is equal to 68. And then x is equal to 8y minus 12. All right, so we started here. What I'm going to do is I'm going to go ahead and follow the same steps as before. Now look at this. The first step was to isolate a variable. We already have a variable isolated in x, right? So what I can do is I can take whatever this value is and substitute it into this equation up here for the x value. If I said x was equal to 3, I could just put the 3 in there and solve. But it says x is equal to 8y minus 12. So check this out. I'm going to take this value right here, and I'm going to substitute it in for x. So what it looks like now is it says 8y minus 12, and I'll put that in parentheses to show I substituted it in there, plus 12y is equal to 68. Okay? Now you look inside the parentheses. Can I subtract those? No, you can't, right? You can't. So I'm just going to go ahead and drop those parentheses. Some of you may have written it without the parentheses, which would have worked in this case, but not in every case. All right, so now we're here. So now we want to combine like terms. So I have 8y and 12y. That will give me 20y minus 12 is equal to 68. I'm going to add 12 to each side, and I get 20y is equal to 80. Oh, that looked weird. And then divide each side by 20. Okay, and that should give me y is equal to 4. And then circle it. Now that we've done that, I'm going to pick one of the equations, right? You can pick one. I could choose to substitute y equals 4 into that one, or I could choose that one. Okay, I'm going to go ahead and just choose the second one. So I'll say x is equal to 8 times 4 minus 12. So I chose this one right here. I'm just going to substitute that back in. And I put the 4 from here back into this equation right here. All right. So what I'll do is I'll say x equals 8 times 4. 8 times 4 is 32. Okay, 32 minus 12 is 20. So I know that y is equal to 4 and x is equal to 20. All right, that was number 2. Number 3. All right, number 3 says x plus 3y is equal to 7, and 2x minus 4y is equal to 24. All right, so in this case, notice that none of the variables are isolated. I don't have a variable that's isolated, but we know how to isolate variables. If we think back to when we were using slope-intercept form, we had to get y by itself and isolate y. In this case, I already see an x here, right? So maybe I can isolate x by itself. The way I can do that is I can take this and I'll say x is equal to, I'm going to subtract 3y from each side here, right? I'll say minus, I don't know why it's not writing, minus 3y. Well, I'll just go ahead and keep what's already on that side. I'll say 7 minus 3y. So I'm subtracting, maybe it's because I'm too close to the top. Maybe that's not why it's not working. But I subtracted 3y from each side here. All right, and that gave me x is equal to 7 minus 3y. Now that I have that, I have to substitute it into the other equation. I can't put it back into the same equation I just messed around with. So this right here has to go in for this x value. Okay, so I get 2 times 7 minus 3y minus 4y is equal to 24. If you notice in these equations, I'm only down to one variable, which is what I want. I don't want to solve for multiple variables at the same time. I want to isolate one variable and work one step at a time. Okay. From here, I'm going to go ahead and use the distributive property. 2 times 7 is 14. 2 times negative 3 is negative 6y. Subtract 4y from there, set equal to 24. Okay. And say 14 minus 10y is equal to 24. Okay. Subtract 14 from each side, and I get negative 10y is equal to 10. Divide each side by negative 10, and say y is equal to negative 1. All right, now that I'm here, I can pick which equation to put it back into. I can pick which one. I'm going to go ahead and just choose the top one. Okay, so I'm going to go ahead and choose the top one. What I'll do is I'll say x plus 3 for y. I'll substitute in negative 1 is equal to 7. Okay, x plus, so I'll say x 3 times negative 1 is negative 3 is equal to 7. And then I'm going to add 3 to each side, and I get x is equal to 10. Okay, moving on. Number 4. Okay, number 4 says x plus 6y is equal to 2. And then 5x plus 4y is equal to 36. Okay, so now I'm here. Once again, I don't have a variable isolated, so I'm going to choose right here. I already have an x. I don't need to do much. I just need to subtract 6y on this side of the equation. So I can rewrite that as x is equal to 2 minus 6y. And then I'm going to take this and I'm going to substitute it back in for x right here. And say 5 times 2 minus 6y plus 4y is equal to 36. Okay, I'm going to use distributive property. 5 times 2 is 10. 5 times negative 6 is negative 30y. Add 4y and set that equal to 36. Okay, now I've done that, I'm going to combine like terms, right? And that should give me, let me see here. Let's see, let's do this. Yeah, I'm looking at this and I was like, this doesn't look good, but it's fine. I was like, it doesn't look like it's going to end up with an integer, but it actually is. I was just looking at it wrong. 30y plus, negative 30y plus 4 equals negative 26y. And then I'm going to subtract 10 from each side. Okay, I get negative 26y is equal to 26. Divide each side by negative 26. And I get y is equal to negative 1. Okay, now that I have that, I can choose which equation to substitute it back into. I'm going to choose the top one again. So lots of movement, lots of things moving around. I'm going to say x plus 6 times negative, 6 times negative 1 is equal to 2. Okay, so I can say x minus 6 is equal to 2. Add 6 on each side, and I get x is equal to 8. All right? Awesome. Number 5. It's good to practice these, okay? It might seem 6 of a similar problem, but it's good to go through and practice these. So 5 says y is equal to 2x minus 1. And then 3x minus y is equal to negative 1. So in this case, I already have y isolated, which is nice. It saves me a step, right? So I can go ahead and take this value and substitute it in down here. But you got to be careful, okay? Be very careful in doing this. So go through this very slowly. 3x minus, that minus is important to keep. 2x minus 1, put that inside parentheses because I'm substituting it in. It's a good habit. Equals negative 1. Now the reason why I want to keep that inside parentheses is because this minus on the outside, like you have to have those parentheses because that minus has to be distributed to 2x and it has to be distributed to negative 1. So what we'll do is we'll say 3x minus 2x, and then a minus times a minus here is a positive, equals negative 1. Okay, that minus has to be distributed to the first term and that second term right there. And even though there's already a minus 1 at the end right here, a negative times a negative makes a positive. So that's why you get positive 1. Okay. And we'll continue. 3x minus 2x is just x. And then x plus 1 is equal to negative 1. Subtract 1 from each side. And I get x is equal to negative 2. Okay, not done. Remember, I have to pick an equation to substitute it back into. I'm going to choose the top one. Okay, so I'm going to say y is equal to 2 times negative 2 minus 1. Okay, so that should give me y is equal to 2 times negative 2, which is negative 4, minus 1, and y is equal to negative 5. Okay. And then 6. 6 is r plus s is equal to negative 12. And then 4r minus 6s is equal to 12. All right, so I'm going to go ahead here and start off by isolating one variable. And I'm going to choose, I can choose either r or s here. Those seem like the easier ones. I could choose one of these down here, but it seems like that's going to take a few steps to do that. So I just see this and I'm like, oh, this could be an easy like subtract to the other side sort of problem. So I'm going to do just that. I'm going to subtract s from each side. Keep on trying to draw an s there, it's not working. And then what that will give me is r is equal to negative 12 minus s. All right, and I'm going to substitute this, the r, whatever the r value is, I'm going to substitute that in right there for r. So I'll say 4 times negative 12 minus s. Okay, and I'll say minus 6s is equal to 12. Okay, and once I've done that, I'm going to go ahead and use distributive property and say 4 times negative 12 is negative 48. 4 times negative s gives me a negative 4s. Then I have negative 6s right there is equal to 12. I'm going to combine like terms, negative 4s, negative 6x, and I get negative 48 minus 10. That looks weird. 10s is equal to 12. Okay, I'll go ahead and add 48 on each side, and I get negative 10s is equal to 60. Divide each one by negative 10, and I get s is equal to negative 6. Okay, now I'm going to take this, I can substitute it into either equation. I'm going to once again just choose the top one because that looks easiest to me. And I'm going to go ahead and rewrite that. So r, Well, it says r plus s, so r plus negative 6 is equal to negative 12. Now, when you add a negative, that's the same as subtracting, so I can say r minus 6 equals negative 12. I'm going to add 6 to each side, and I get r is equal to negative 6. And that's my answer. All right, so we've worked through 1 through 6, and it's good to work through multiple problems, and our steps do not change. I'll even go back to the beginning. All right, if I go back to the first one here, the substitution steps never changed. We isolated one variable, didn't matter which one. Okay, then we take that value and substitute it into the original equation, the other equation, and then solve the equation, get an answer. Okay, so right here, if you look at this, we solved and got this. We then took the answer and substituted it in one. Doesn't matter which one, I could have chose either one, substitute one of the original equations, and solve for the variable that you don't already know. Okay, and then it's good to check your work. You can always go back and check your work and make sure everything goes back in. Okay, I didn't check my work on most of those problems, but I think it's important just to go through and continue to do that. All right, so now moving on to elimination. Okay, we've been solving systems by substitution, so now we're going to be solving systems by elimination. Okay, and there are several steps that I'd like to follow in doing that, but elimination, some people they like elimination more. Sometimes you can't use elimination on certain problems. You're going to have to move things around. You can always find a way to use substitution, but it might be difficult times to solve by graphing or elimination. Still an important method to know, because in some cases it could be quicker, right? It's like having this in your arsenal of potential ways that you could go ahead and solve a problem. So solving systems by elimination, I'm going to go ahead and answer the problem a little bit lower and then add the steps above as I do it. All right, so the first problem is x plus y is equal to 12 over x minus y is equal to 2. All right, so when I'm going through and I want to solve by elimination, the first thing I want to do is I want to line up, I'll say vertically, variables that are the same. So I could also call that like terms. In this case, look, we have the x's lined up, the y's lined up, and then I have my integers left at the very end there, okay? And I can use them. My coefficients in this case are the same on both, so it's going to be an easier representation. But I'm going to look at this and say, all right, have them lined up. The second thing you want to do is you want to think, if I were to subtract going down, like if I ever had, like, I don't know, let me see, 25 minus 14, right? If I wanted to solve that, I would solve going down, right? And say 5 minus 4 is 1, and then say 2 minus 1 is 1. Or if I were to solve, like, I don't know, like 44 minus, I don't know, say 11. Say 4 minus 1 is 3, and 4 minus 1 is 3. So you're going to decide which variable you want to solve for, and you'll say add or subtract vertically. And you're going to have to make a decision whether you add or subtract here. And I'm going to say add or subtract vertically so that you eliminate one variable. So for example, in this in this problem right here, this is number 7, right? In this problem, if I were subtracting, right? Let's say I just choose subtraction as an option. If I say x minus x, that eliminates the x, and that would give you 0, right? X minus x is 0. Something minus itself is 0. So that would work in this case. And then I'd say y minus negative y. If you subtract a negative, that's the same as adding a positive, right? So y minus negative y. That actually gives me y plus y. Y plus y is 2y. And then 12 minus 2 is going to be 10. Okay? I'll go ahead and take that circle out. There you go. And then I just solve, right? Once I've done that, so I'll say my third step is going to be solve the equation. Okay, and I get y is equal to 5. And then from here, what I do is I'm going to go ahead and I'm going to use substitution to find other variable. Okay, so in this case, I said, all right, y is equal to 5. So I'm going to go ahead and substitute that into my top equation here and say x plus 5 is equal to 12. What plus 5 is equal to 12? Well, if I subtract 5 from each side, I get x is equal to 7. Okay, and that's my answer. And the way you can check it, I guess the fifth step, if you were to come up with the fifth step, is check your work. So if I'm drawing this here, I know I'm making it kind of looks like the United States, right? They got like Florida down there. So if you substitute these values back in and check your work, you say 5, which is y, plus 7 equals 12. Okay, negative 7 minus 5 gives me, negative 7 minus 5 could be a positive 2. Okay, and that is number 7. All right, number 8. Number 8 is x plus 2y is equal to 10, and then x plus y is equal to 6. All right, so in this case, everything's lined up. Okay, I have everything lined up. If I wanted to make it look even neater, right, I could do this. I could say x and then line up my plus right here, plus y is equal to 6. And if I subtract, in this case, going down, that would take out my x value, right? X minus x is 0. So then 2 minus, really there's a 1 there, right? So 2 minus 1 is just 1, which is y. And then say y is equal to 10 minus 6, which is 4. Remember, 10 minus 6. That would give me 4. Once I have that, I'm going to substitute into the original equation so I can choose which one to use. And I'm going to go ahead and use the top one and just say x plus 2 times 4 equals 10. Okay, x plus 8 is equal to 10. Subtract 8 from each side. I get x is equal to 2. All right, I went ahead and solved that one. Let's do number 9. Okay, number 9 is 3a plus 4b is equal to 9. And then negative 3a minus 2b is equal to negative 3. All right, so here's the thing. 3a, and I have a negative 3 at the bottom. That does not mean subtract them because that's just the terms. If I add a 3 plus a negative 3, right, if I say like 3 plus negative 3, that's the same as saying 3 minus 3, which is really 0. So I want to add these two together. So I'm going to put a plus here to add them together. So 3 plus negative 3 gives me a 0, right? Which then cancels out everything there. Then I could say 4 plus negative 2 gives me a positive 2. So 2b, that's the same as saying 4 minus 2. And then 9 plus negative 3 gives me a 6, right? And divide each side by 2, and I get b is equal to 3, right? And then I pick which one I want to substitute it back into. I can do the top one. I'll say 3a plus 4 times 3 is equal to 9. Say 3a plus 12 is equal to 9. Subtract 12 from each side, and say 3a is equal to negative 3. Divide by 3 on each side, and I get a is equal to negative 1. And that was number 9. Number 10, I got 2 more elimination problems. Right, number 10, I have 4x plus 2y is equal to 4. And then I have 6x plus 2y is equal to 8. Now in this case, right, these 2's line up and seem pretty easy to eliminate. It's as simple as subtracting them, right? So in this case, I'm going to get rid of the y's. And 4 minus 6 gives me a negative 2. Set that equal to 4 minus 8, I get a negative 4. And then I'm going to go ahead and divide by 2 on each side. I get x is equal to a positive 2. Then I'm going to choose one of the equations to substitute it back into. I'm going to choose the first one to say 4 times 2 plus 2y is equal to 4. 4 times 2 is 8. Plus 2y is equal to 4. I'm going to subtract 8 from each side. Say 2y is equal to negative 4. And from there, divide by 2 on each side and say y is equal to negative 2. Okay, and those are my answers. Last one, we're starting to get the hang of this. We're going to do number 11. Number 11 is 2w plus 5y is equal to negative 24. And say 3w minus 5y is equal to 14. All right, so if I want to get rid of 5's, right, these 5's right here, they line up pretty well. If I were to subtract, that wouldn't work, so I'm going to add them together, because if I add positive 5 plus negative 5, that gives me 0, and they cancel out. Okay, so 2w plus 3w is 5w. Negative 24 plus 14 gives me a negative 10. Divide each side by 5, and w is equal to negative 2. Okay, I'm then going to pick which equation to substitute it back into. I'm just going to choose the top one. You can choose either one. I'll choose the top one. Plus 5y is equal to negative 24. 2 times negative 2 is negative 4. Plus 5y is equal to negative 24. Okay, add 4 to each side. is this ugly? I'll go ahead and rewrite that. Add 4 to each side, and I get 5y is equal to negative 20. Okay, and then divide each side. Whoops. Divide each side to y by 5, and say y is equal to negative 4. Okay, so I've completed numbers 1 through 11 so far. And we're going to move on to number 12. We're going to move to systems of inequalities. And this works very similar to the way when we were graphing systems of equations. So if you look at number 12, you have y is less than or equal to 2x plus 2, and y is less than negative x plus 1. Okay? And what we're going to do is we're going to create, I'll go ahead and pick one inequality at a time here. I'll say 2x plus 2. And I'm just going to treat this just like this right here was an equal sign. I'm just going to treat it like that. And I'm just going to pick two values because you only need 2 points for a line. And I'm just going to choose 0 and 1. Those are good ones to choose. And substitute those values in. So like 2 times 0. 2 times 0 is 0. 0 plus 2 equals 2. Let me try 1. 2 times 1 plus 2. 2 times 1 is 2. Plus 2 is equal to 4. Okay. And then I'm going to draw my coordinate plane. So I have my y-axis and also my x-axis. I'm going to label each. That's my y. That's my x. Okay, and I have 0, 2, which is the first one. So I'll go 0, 2. And then 1, 4. 3, 4. Now, once I've gotten this far, I'm going to, just like I did before, I've already graphed these before. Remember that if I have my 4 basic inequalities, less than, greater than, less than or equal to, less than or equal to, greater than or equal to, right? These are my 4 basic inequalities. And anything that is less than or greater than is going to use a dashed line to connect them, whereas these are going to use a solid line, right? So this is going to use a dashed, these two, I'll draw like a thick line between so you can tell the difference, and this one's going to be a solid line. So we're using, in this case, it says greater than or equal to, so it's going to be a solid line that connects it, right? And then am I going to shade above or below, right? So this is going to be all the values that are less than. And I'm going to choose a color. Check this out. You can use colored pencils. You can, so let me change it there. Oh, here we go. You can choose a value. You can choose whether it's just like a colored pencil or just maybe you're just like going down, right? That might be one way of signaling this one graph because we're going to graph more than one, right? So maybe for this one, even if you don't have different colors, maybe you just say, all right, all those are going down. Because now we have to graph the other one, right? So I don't even know what color I had before that I was drawing with. I wonder if I have the paint bucket tool. No. It was like a greenish, I don't know what I had before, right? Oh well, I don't care. And we're going to graph the second one. So we'll say y, that's not bad. Y is less than negative x plus 1. So I create my table here, right? And I'll use 0 and 1. If I use 0, 0 plus 1 is equal to 1. And again, once I start, I'm just treating this as an equal sign. So that's how I'm going to solve it. And then I just looked at what I did in the previous example, and that looks really ugly. You probably can't even follow. 0 plus 1 equals 1. And then I'm going to go ahead and substitute in 1, so I'll have negative 1 plus 1, which will give me 0. Okay, so if I were to do that, if I graph these 2 points, 0, 1, which 1 is right there, 0, 1, and then 1, 0. And if I draw a line that goes through the 2, and I shade all the values. Well, before I do that, skip the important step. This right here is a dashed line, right? We already determined that from up there. Almost made a big mistake. So I'm going to use a dashed line. And all the values that are below. So maybe I'll change my color. And if you don't have color pencils or different color, that's fine. You can just use like a side-to-side motion. So all the values that are less than... I don't like that color. Let's see if I can get it brighter, like red. There we go. Okay, all the values that are less than that line. Like I said, if you don't have different colors, you can just maybe do a side-to-side motion or pick a pattern of what you like. All right, so now the solution is going to be, maybe I'll choose like a bright green color here, right? Right, the solution is going to be all of this, right? All of the overlap between the two colors, the kind of brownish gold color and the red, that's going to be the solution. So wherever there's overlap of the two colors, that's where the solution is. Okay, and that's going to be my answer for that one. Number 12. So moving on to the last problem, number 13. Number 13 is x plus 2y is less than or equal to 10, and then x plus y is less than or equal to 3. And in this case, for both, I want to isolate y. I want to get y by itself. Okay, so this one right here, what I can do is I'll go ahead and take that first inequality, say x plus 2y is less than 10. So this is just what I started with. I'll just put a box around it. And I'm going to say, all right, I want to get y by itself. So let me subtract x to the other side, right? And I get 2y is less than or equal to negative x plus 10. And then I divide everything by 2. Right, divide everything by 2, and I get y is less than or equal to negative 1/2 x plus 5. All right, so if I'm making a table for this one, right, I'll go ahead and create my x, y. Now I have isolated y. All right, I'm going to go ahead and just use 0, 0, 5. That's an easy one. And then another good one that I could use here is 2, right? Because if I have 2 on the bottom here and I multiply it by 2, that gets rid of it, and that would give me a negative 1. Negative 1/2 times 2 gives me a negative 1. All right, so I'm going to go ahead and create my coordinate plane. This is my y-axis, this is my x-axis. My first one is 0, 1, 2, 3, 4, 5. My next point is 2, 1, 2, and down 1. All right, this shows me that I'm going to use a solid line here, right? We know that we have a solid line because of that inequality. So I'm going to go ahead and, draw a line. It goes through both points. and all the values that are less than. So I'm going to go ahead and I'm going to shade in everything on this side of the line. I'm just going to go up and down. Everything on this side of the line. And I'll continue over here. Awesome. All right. And then my other, so I've already, I graphed this one right here. Now I want to graph this one. And what I would need to do is, I need to take x plus y is less than or equal to 3. Okay. And you get y by itself. So what I would do is I would just subtract x on both sides here. And I get y is less than or equal to negative x plus 3. Okay, so if I were to create a table of values, I can go ahead and say 0, and I'll use 0 and 1. This will be easy. Okay, 0 plus 3 is 3. 1, negative 1 plus 3 is a positive 2. Okay. And then from here, plot my 2 points. I have 0, 3, and I have over 1, up 2. Right. And I'll go ahead and draw my line that goes through these two. And go ahead and add that there and there. And I'm shading all the values less than or equal to. So all the values that are less than, so everything below that line right there. And although it might seem like a lot of the values are overlapping, right? Not all of them overlap, but a lot of them do, right? So you see, if I use different color to show you what's actually overlapping here, everything from like here all the way over here, infinitely that way, and then down here, right? Those are the values that are overlapping. So you see that like down here, there's no overlap, and then over here, there's no overlap. Everything else is overlapped. Those are the solutions. And you don't need to circle that area. I can just tell. It's nice if you use different colors, so that way you can tell the difference between the two, rather than this looks kind of sloppy, right? Compared to the last one, I think that we can agree that this one, even though it isn't perfect, it looks a little better, and you can more easily tell where the overlapped colors are. Okay, on number 12, right? But that was number 13, and that was the last problem on here. And let me know if you have any questions.